All right, let's get right into it. Today, we are going deep under the hood of one of the hottest topics in tech right now, AI agents. And believe me, we're about to see why they are so much more than just a smart chatbot. I mean, it's easy to see why, right? You type in a question, you get a pretty smart answer. It just feels like you're talking to a chatbot that's maybe had a little too much coffee. But honestly, if that's all you're seeing, you're missing the entire picture. Because what's really going on under that simple surface is, well, this. It's a whole ecosystem, a complete blueprint for an autonomous system. Just look at all these interconnected parts. Understanding this anatomy, that's the real leap. It's what takes you from making a cool little demo to actually engineering the next generation of autonomy. So let's break this whole thing down. Okay, first things first. Let's start right at the heart of it, the agent's core. You can think of this as its brain. It's where all the heavy lifting, all the thinking and coordinating actually happens. So inside this core, there's a really crucial distinction we need to get. On one hand, you've got the LLM, the large language model. We all know this part, right? It's the linguistic engine. It gets language, it generates language. But the real brain, the thing actually in charge, is what we call the MCP, the memory, control, and planning system. See, this is the integration layer. It's what connects that language part to actual tools, to APIs, to real-world services. It's what turns talk into action. Okay, so a brain is great, but a brain without memory? Not so useful. So let's move on to the memory backbone. This is the absolute foundation that lets an agent learn, adapt, and get genuinely intelligent. And we're not just talking about one kind of memory here. There are actually 4 distinct types working together. You've got semantic memory, which is for facts, the what is this stuff. Then there's episodic memory, which is all about past experiences, the what happened when part. Working memory is like the agent's short-term scratch pad, keeping track of what's happening right now. And then you've got the 4th one, and this one's a big deal. And that's procedural memory. Honestly, this is the absolute secret sauce of the whole operation. This isn't just about remembering facts. It's about remembering how to do things. It's how an agent learns from what it does, refines its own strategies, and just gets smarter at solving problems over time. This is what makes it dynamic instead of just static. So we've got a brain, we've got memory. Awesome. But how does this system actually connect with the real world? Well, that's where this continuous cycle comes in, and it's called the perception-action loop. It all kicks off with perception. And look, the agent isn't just sitting there waiting for you to type something into a box. No, it's actively pulling in live data from all over the place. We're talking sensors, APIs from other apps, databases, even just messy, unstructured data from its environment. So once it perceives all this stuff, it has to make sense of it, right? That's the reason step. It processes all that incoming information in real time, connecting what it's seeing now with everything it already knows from its memory, all while keeping its main goal in mind. And finally, based on all that reasoning, the agent acts. And this is where it gets really powerful. Acting isn't just spitting out some text. We're talking about triggering actual real-world workflows, executing commands, firing off emails, or in the world of robotics, even making something physically move. This leads us to a super important part, the agent's thought process. You see, before a truly autonomous agent acts, it doesn't just react on instinct, it plans. This is its cognitive engine really kicking into gear. And this whole planning thing happens in this incredibly fast cycle. First, it comes up with a thought, basically a potential plan. Then it evaluates that plan. Is this a good idea? Will it work? From all the different possibilities it came up with, it selects the best one. And only then does it actually execute the plan. And right there, that planning cycle, that is the fundamental difference. It's what separates a simple bot that's just mindlessly following a script from a true agent that you can give a complex mission to and it will figure out for itself how to get it done, adapting along the way. Okay, so we've looked at the brain, the memory, that crucial interaction loop, and the planning pipeline. Let's pull the camera back now and look at the big picture one more time. And here it is again, the whole blueprint. The internal core, the memory, the pipelines, they aren't just separate blocks. They are deeply connected. They're all working together as one single, cohesive, autonomous ecosystem. What we're really looking at here is a massive evolution. We're moving way beyond just typing prompts and getting back answers. We are literally building autonomous digital workers, systems that can observe, plan, act, and most importantly, learn from the results. So that's the anatomy of autonomy. And it really just leaves us with one huge, exciting question. Now that we can build systems with this level of independence, what are the big, complex, real-world missions we're going to set them on next?